Welcome. This is my final review video for y'all before y'all take your semester exam. Maybe just say a couple of quick things before y'all listen to this video. But thank you so much for being in my classroom, doing your best. I mean, if you're taking the time to listen to this video, you've probably been actually working hard in my class, and I do appreciate that. Thank you so much, and good luck to y'all in the future. Anyways, let's look at the next set of problems. Alright, so here we go with number 90. We have 4 over w minus 2 equals negative 1 over w plus 3. So here we need to find the LCM. And more like with these type of questions, I could do 2 and make you give me two different, or give two answers. One, find the LCM, which is w minus 2, w plus 3. And then, if you multiply the first one by the LCM, the w minus 2's would cross out, leaving you 4 times w plus 3, which would be 4w plus 12. The second one, the w plus 3's would cross out, then leave me negative 1 times w minus 2, which would give me negative 1w plus 2. Variables to the left, numbers to the right, and then you could divide after that. So 4 plus 1 is 5w, 2 minus 12 is negative 10, divided by 5, you get negative 2. Simple, easy peasy, right? Yes, I believe so, sir. Let's go to the next one. 91. What is our least common multiple here? What's our LCM? It would be the x minus 1, x minus 2. So I would multiply all three fractions by x minus 1, x minus 2. Oh no, I wrote x plus 2. Let's fix that. Okay, so here I would cross out the x minus 1s and say 6 times x minus 2, which would give me 6x minus 12. And then over here, when I say x minus 1 times x minus 2, the x minus 2 would cross out, leave me 4 times x minus 1, which is 4x minus 4. And then over here, I would have the x minus 1 times the x minus 2. The x minus 1s would cancel out, leaving me 2 times x minus 2, which would give me positive 2x minus 4. So, combine all my like terms, I have 6x minus 12 equals 4 plus 2 is 6x minus 8. And if you notice here, the x's would cancel out. If I move this variable here, the number over here, I'll have a plus 12 here, minus 6x here. Those cancel out, leave me 0, because the 12 is gone. And over here I would have 4. 0 is not equal to 4, so this one is a no solution. Whether or not you will actually have one of those on the actual test, I don't know, but we shall find out. Alright, so for 92 and 93, I'm just going to show you the answers because those are the ones we just covered with the whole vertical and horizontal asymptotes. And those ones you don't have to factor. So keep in mind again, like your vertical asymptote is here with the x, your horizontal, and notice that it's the opposite. Your horizontal asymptote is the number that's all by it's over after the fraction. That one stayed the same. And then there are no wholes or zeros because there's no extra factors to cancel out, and there's no extra factors that could be on top of the in the numerator. So I could ask lots of different questions here, so kind of keep that in mind. And then on the next one, I do have to say on 92 and 93, you can see the answers. And then on 94, okay, so for here 94, you can see that I'm going ahead and factoring. A minus minus is or minus plus is a minus minus. Two numbers that multiply to give me 2 add up to 3. So these I have to factor. Two numbers that multiply to give me 6 and add up to 5 are 3 and 2. I can see the x minus 2's would cross out. Those will become my wholes. So with those, I would say, remember, think opposite. So my wholes are going to be at x equals 2. The vertical asymptote is the denominator, so that would be x equals 3. And the 0 would be at the numerator, which would be x equals 1. So you might want to make note of that because I feel like I can make a lot of questions from this, and hopefully it should be easy points for y'all. Horizontal asymptote again is looking back at the original, the beginning. 1 divided by 1 is 1, so y equals 1. And then what is the domain and range? It's all real numbers, but it cannot equal 3 and it cannot equal 1. So kind of keep in mind how I'm saying that for the test. Let's look at the next one. So same thing. Plus minus is a plus minus. Two numbers that multiply to give you 18 and subtract to give you 3 is 6 and 3. On the bottom I can take out an x, and that would leave me with an x minus 3. So x minus 3 is where my whole is. That would be 3. X is 0 because it's just an X. The vertical asymptote was at 0. The zeros are at -6, again the opposite, and then again horizontal asymptote is at 1. So that my domain cannot equal 0 and cannot equal 1. And then we're getting to the word problems, which look like they would be hard, but they're not going to be so bad. Don't worry. Alright, so for problem 96, you need to go ahead and visualize. So, like, okay, so here's a rectangle, there's a width, and the length is 5 centimeters longer than the width. So, add 5 to the width, and you got the length. And they tell you the area is 84. Now, can you, say, come up with a equation that goes with that? Well, keep in mind, for area, you multiply. So you're saying W times W plus 5, and that equals the area of 84. Well, W times W is W squared. W times 5 is 5W equals 84. So I'm going to move the 84 to the other side. And there is my equation. Now, in theory, you should be able to graph that and see where it crosses the x-axis and only go with the positive answer. But this one's also factorable. So we can see here, what's two numbers that multiply to give me 84 but subtract to give me a 5? And that would be 12 and 7. And then keep in mind the answer, final answers would be the opposite of those numbers in the parentheses. So the opposite of a plus 12 is minus 12. And the opposite of a negative 7 is positive 7. And since I can only take the the positive answer, I cross out the negative because this is an application problem. The answer is 7. You can go ahead and omit 97 for 98 you need to graph. Now, the question on 98 is that it says there that it's when does the ball hit the ground? When does it hit the ground is a 0. And the way we can get that again is menu 5-1. Do not forget menu 5-1. And if you do that, it would tell you that it crosses at 2.25 seconds. But again, menu, oy vey, my pen is just not writing well today. Menu 5-1 to get to that point. Okay, so for number 99, I went ahead and graphed it, and I did the menu 5-1. Keep in mind, when I first did the initial graph, I couldn't see everything. So when I hit menu 5-1, it allows me to go up. I'm looking for when it's a 0. So like when part A, it asks when does the hit the ground, or how long is it in the air? Well, from 0 to here, that's 5 seconds. But again, you could tell, like when does it hit the ground, that's a 0. Okay, then to find B and C, you got to find the maximum. So you got to get this point right here, and you can tell that it's at 100 feet, it reaches its max height, and it takes 2.5 seconds to get there. D and E, you can find those again through your menu trace, and you would get an answer that's close, menu 5-1. But I'm probably not going to have questions on that. I would stick to more like maximum height, how long in the air, or when does it reach its maximum height, things like that. Anyways, that's it for 99. Now, let's eliminate quite a few problems here. Let's get rid of 100. I'm not going to give you like 100, 101, 102, even 103. I'm not going to give you problems where those are, I decided, I've looked at the quiz or the test, and it's not just going to be on there, okay? But I will give you one like 104. Notice that one, I give you the function. And so you just got to graph. It says how long is the arrow in the air? Well, you find out when it hits the ground, and it says there, according to the graph, 4 seconds. So you can easily find that answer. So there you go for that one. Okay, so let's keep going on number 105. We've got 128 equals 4 to the x. This is, again, one of those types where you would have to use your exponent table. You would easily see it on the 2. I don't know if you see it on the 4, but like 4 is 2 squared, 128 is 2 to the 7th power. So then I could convert both of those to that. I can drop the big 2's and say 2x is equal to 7 and then divide by 2 to get x equals 7/2. And that's it. So like problems like 105, 106, 107, 108, 109, even 110, you can use your exponent table. After that, you get to logs. Okay, so you can see here I'm converting the 4 to 2 squared and 32 to 2 to the 5th. And so that would leave me with a 2 times 2x, or 2 times x plus 1, that gives me 2x plus 2 equals 5, because I can drop these big 2's. These are gone. And then I can subtract 2 and then divide by 2. And so x is equal to 3/2. Okay, 107, same thing. You would find on your, again, this is an exponent table that you can have on your note sheet. 1 over 27 is 3 to the negative 3 power. So then I can just say x is equal to negative 3 because I can drop the big 3's and I'm done. Ooh, I like 107. 107 is a great problem. Great problem for the test. 108, 1 over 32 is 2 to the negative 5 power. Notice how these fractions are negative exponents. So I have negative 5 equals 1 minus m. I move the variable to the left, number to the right, and that would give me a positive m is equal to 6. 1 plus 5 is 6, and I'm done. See, I like the simple problems, the ones that are nicer. Anyways, 1/9. Dang nab. 81. I think when I gave you all the exponent tables, I didn't worry about powers of 9. So you would see on your exponent table that 1 over 9 is 3 to the negative 2 power. And 81 is 3 to the 4th power. And so then again, you would just like drop the 3's and say negative 2 times m is negative 2m. 4m times 4 times m plus 4 is 4m plus 16. Move the 4 over, divide by negative 6, and you get m. 16 over negative 6 would simplify to negative 8/3. And there you go. Number 110. 25 is 5 squared. I don't know if I would do a problem like number 110 for the real test. This is going to set you up to a quadratic. I mean, it's not hard, but one thing I do want to point out is look at how you would factor it, because you can factor it. If I did give you something like that, it would be definitely factorable. So I have moved this 2x over to the other side because I want my x squared to be positive. And minus minus is minus plus. Two numbers that multiply to give me 15 and subtract to give me a 2 would be 5 and 3. And then again, if I was solving it, the opposite of negative 5 and 3 is positive 5, negative 3. Easy peasy, all done. Alright, so starting at number 111, you have to start doing like logs. So like here, okay, so how do I get e by itself? And so I divided out the 12. And then how do I get rid of an e? Put a natural log. Okay, so natural log of e, the ln e cancels each other out, leaving me 3x minus 2 equals ln of 8 over 12, which is negative 0.405. And then I could say, go ahead and add 2, divide by 3, and get my final answer. 1 second. Notice that when I said 2 plus negative 4.05, or negative 0.405, that gave me an answer of 1.595, and then divided by 3 to get that answer. Number 112, I would need to subtract 1 first, and then remember, to get rid of an ln, you have to do an e. But keep in mind, you actually should move, before you can do that, you should get rid of exponents. You should never have an exponents before you try to get rid of like logs or natural logs. So I'm going to move the 2 over to the other side and say ln x equals 1, divide by 2, and I get ln x equals 1/2. Then I can use my e to get rid of the ln, so that would leave me with the x only, and then I would type in the calculator e to the 1/2 power to get 1.649. I hate that bell. Anyways, moving on, 113. Again, here, oops. Here you would have to use logs, so you got to get the 1.08 by itself. Let me back that up a bit because that's kind of confusing, to be honest. So first off, divide by 5. And so you get 23 divided by 5 is 4.6. And then to get rid of the 1.8, since there's a t power, you'd have to use a log. So you'd say log of 4.6, log of 1.08. And see, because of that, we can move the t in front of it, and then that means we're treating this like a number. Log 1.08 is a number, and I can divide by it, so I can type into the calculator like those two divided and get my final answer of 9.829. Yes, R2 is telling me we must hurry and finish this up. We're getting there. Alright, so let's look at 114, shall we? And we have log 12. Remember, when you have the same base log, you can drop the logs if they're one on each side. So I can drop it and say 7n plus 2 is equal to n squared plus 12, which then becomes more of a quadratic equation. I can move the 7n and the 2 to the right because I always want the n squared to be positive. So that would leave me with n squared minus 7n plus 10 is equal to 0. And minus plus is a minus minus. Two numbers that multiply to give me 10 and add up to 7 is 5 and 2. Again, the answers would be the opposite of those in the parentheses, so the answer is 5 and 2. I don't know how many of those you would get. Here's another one where you have to use natural logs to get rid of them. So again, divide the 2 first, and then use the ln to get rid of the e, and so you would find out that x is equal to 0.693. For 116, same thing. First do the ln, then you're going to divide by 3. So notice how there's a difference between those two. When do you get to use the ln and when do you get to divide? And that was mainly because the 2 was in front of the e, whereas the 3 is part of the exponent. So that's how we do that. And you can see those two answers. 117, how do I get rid of ln? Use an e. So e to the 2x equals e to the 4th, because that, I'm sorry, 2x would equal e to the 4th. And then you can divide by 2 to get whatever you get, 27 something. I'll wait till the answer actually shows up on here and see what it says. Why not? 118. Okay, that one again you would have to use a log. You'd move the 2x over to the front, so that allows me to do that. I can divide log 8 by log 10, and then I can divide that answer by 2, and that will give me my final answer, which would be whatever it may show up to be, 0.4 something, 45 something, 0.452. Sure, why not? And really, folks, that kind of reaches our limit. So I'm going to say 119 through 125. We can, let's see here. You can omit. I think you've seen some of those, like 123 and 124, 125. And so you're kind of good there. We'll go ahead and say 119. Okay, so I'll say you can omit 119 through 123 and 125. 124 is pretty easy, so I'm going to go ahead and do that one. I mean, I could probably do 125 also, but whatever. Okay, so keep in mind, I can rewrite this in exponential form. So if this is saying the base is 3, this, remember, is the exponent, 2.5, and I'm saying that it's equal to x. So really all I'm saying here is I need to know what is 3 raised to the 2.5 power. And then whatever I get, or 2.5 power, however you want to read that. So 3 raised to the 2.5 power, according to my calculator, tells me that x is equal to 15.58. That is an 8. Let's try that again. Try that again. 8, 9. And you're done. So that one's pretty easy. Anyways, that's it. That's it. We're done with the review. I've covered all the problems I would like to cover. Good luck on the test, and we will see how y'all do. Thank you so much for your time. I know this has been long, 5 videos, but I do appreciate your patience. Thank you. Y'all take care.